That's helpful.
But yeah, I know that my friend who works at the daycare just got sent home, sort of thing, so she can't, see what that's gonna be like.
A private one or like a.
She works at a government one, I guess, and so yeah, she's happy to be sent home, but morning everybody, nobody on stream yet. That's okay. Well, hopefully somebody will come back. We are not going to do the quantitative chemical changes today. We're going to do this. All right. So actually, we are done that booklet. Let's get into science. And we need book 3, or we can go to the overhead. Do you want to? Do you want to teach or?
Whatever, yeah.
No, you're always whatever. So, we can go straight to. You can use the overhead if you want, or
The visualizer.
the visualizer.
Yeah.
And then we can do it on paper.
Yeah.
Okay, so we'll let Matthew get a little bit of teaching in, considering his block of teaching has been sort of thrown into disarray a little bit, but a little bit's better than nothing. So we're gonna go to the acid-base unit. So please find that booklet somewhere in your files. If you don't have a copy,
Would we still need this up?
you'll need that still, yeah, probably. So that'll be this booklet here. This is going to be today's lesson. I see someone's up there. So just if you're just joining the stream, then we're going to be working on this acid-base booklet today. And I'm going to let Matthew take over, and I'll be around to help out.
Does it record the visualizer?
Oh, great. Let's put that up there. No, I just got to do this so that I can. How do I go to full page?
John,
Good enough.
one of the last question for the assignment yesterday
Yep.
was actually about acids.
Oh,
So I couldn't actually get into that. I'm like, we didn't get into acids yet. So
well, then we'll
Yeah.
get into it now. So
I'm like, yeah, okay, we haven't.
that's
touched
totally
it,
fine.
so-
Yeah, we do what we can, and then if it works out,
Yeah.
Yeah. So that's fine. If you weren't able to do that one, then we'll.
I couldn't get into that one. I'm like, okay, we didn't get into it yet.
Well, this will be a good chance to get in there, and then
I
we
know.
can come back to it.
I guess the microphone records the audio.
There's a microphone on that green stand that's recording for you right now, and then that's just for the rest of the class.
Okay, so today we're just gonna start the acids and bases part of the Science 20S course. So pretty much today just gonna talk about properties of acids and bases, and we're also gonna look at some. Pardon?
It's backwards.
Yeah.
Because
wonder why.
It reverses the mirror afterwards.
What did they see on this?
Let me just think about it.
What are they seeing in the live stream?
The live stream will be correct. It's just that it's because I'm using a different thing. Okay. Let me just think about it. You keep talking. They don't need to see it. It's okay.
Okay, so first of all, we're talking about acids and bases. What do we think acids are? How would we define an acid? Does it taste a certain way? Does it look a certain way?
Well, in a way, you got citric acids, which are from fruits like oranges,
Oranges?
to a very harmful acid to your skin.
Yeah, there are definitely some harmful acids. So in general, acids are sour tasting. So if you think about your sour candies, they have citric acid on them, or lemon juice or orange juice, vinegar. So pretty much all acids have that sort of sour, sharp taste. Yeah, and they're very reactive as well. So one of the reactions that we look at is the reaction between a metal and an acid. That's the first one we're going to look at. So in general, if you have a metal reacting with an acid, you're going to get a salt and you're going to get hydrogen gas.
Looks like you're having fun, John.
Yeah, I'm having a good time back here. Don't worry about it. It's all good.
Okay, so if we look at an example, so for example, if you mix solid magnesium and hydrochloric acid, which is an acid, what salt do you think we'll get? If we're gonna get hydrogen gas, what do you think the salt will be in this reaction?
Okay. I'm gonna have to go to the other format here.
Pardon? Corrosive, okay. But what salt do you think we'll get here? If we're mixing magnesium and hydrogen chloride or hydrochloric acid, we're gonna get hydrogen gas. And what do you think the salt will be? Magnesium chloride? Okay, and what would the formula for magnesium chloride be? MgCl, okay. So we have, what's the charge on magnesium? Two plus, okay, what's the charge on chloride? Okay, so it's gonna have a -1 charge, right? So if we cross those two ions together, what's the formula of the salt gonna be? Yeah, so it's gonna be MgCl2. Okay, and what type of reaction is this? We were just talking about this yesterday. Okay, not quite combustion because we don't have carbon or oxygen.
Almost there, guys.
We can see the magnesium and the hydrogen are switching places, right? So it's a single replacement, yep. Okay, so this is a single replacement reaction, but you'll learn we can actually use a new term to define this type of. Actually, no, this isn't a neutralization because we're not getting water. Yeah, so we would still say this is a single replacement reaction. Okay, so I want to do another example just so that we can get confident with that.
Now it's upside down. Maybe can you do it on the board? Can you do it on the board for now?
Yeah.
And then I'll try that. Let's see why everybody's.
So just want you guys to spend a couple of minutes trying to complete this chemical reaction. So just completing it, so we have sodium metal mixing with hydrogen bromide to give us a salt and hydrogen gas. I just want you to come up with a balanced chemical equation for that reaction.
So you can do. You don't have to ask the base booklet. Let me know. Here. Well, I'll go. That's fine.
So that's right so far. On the left hand side. Okay, so we're pretty much talking about hydrogen on metal reacts with an axis. We're going to get a salt and hydrogen gas. So like in the first example, the metal was magnesium. Magnesium is Mg. And the acid was hydrochloric acid, which is HCl. So this is the metal. This is the acid. And when we react together, we get a salt and hydrogen gas. So we get H2. And what do you think the salt would be? We have to get that 100. What would be in front of? Right, that's correct. So what pretty much happens here is right, the H and the Mg so that single phase reactions that we talked about yesterday. So just want you to try the one on the board with sodium metal and hydrogen bromide. Instead. So it's pretty much that we did the single replacements. So you can get that one right. Looks right.
You put it up on the board, and then you write on there, and then just scroll with your fingers.
Sodium and bromide, they're both, well, sodium is a +1 and bromide is -1.
Okay,
So wouldn't they kind of equal each other out?
okay, so you were saying that the charge on the bromide is -1, is that what you were saying?
Yeah,
Okay, so if the charge of bromide is -1 and hydrogen
hydrogen is +1.
+1, right? So what would the formula of hydrogen bromide be?
It would just be,
Just put it up on the, like, right on the board, and then.
HBr.
Right, that's correct, yeah.
And if you write within here, then the live stream can see you, so they're pointed at this screen here, so if you just write it here, then they can see it as well.
So you said hydrogen had H plus, right? And bromine had,
Bromine had -1.
yep, so the formula would be, but,
It would be NaBr plus H.
Okay, so yeah, the formula for sodium is Na, so that's our sodium metal. And the formula of the acid would be HBr, right? Because we crisscross the 1 and -1. And then what would the products of that reaction be?
NaBr plus H.
HBr, okay. If it's hydrogen gas, is it gonna be just H or is it gonna have a slightly different formula?
Tricky one. Part of our clown, right?
Yeah.
The half wrinkle thing?
Yeah.
Thank you.
Actually, if there would,
It would be,
just one. And it would equal everything out.
okay, so remember, when we get hydrogen gas, it's always gonna be H2. It's not ever gonna be H by itself. So our diatomic molecules like hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, they're always gonna be diatomic. So you'll always have two of them.
And then that gives bromine 2.
Oh, now you're doing the balancing?
Yep, so now we would need the balancer, right? So we only have one H on the left-hand side, and we
Yeah.
have two H's on the right.
You would put an H on this side also.
So you really need to
Put
put
a 2
a,
on this side.
a 2 here,
Yeah, you can balance it out.
okay, and a 2 where?
For another NA.
But,
Another
yeah,
two
then
for
you
another NB, NA here.
Yep, so that looks balanced so far. So we have two NAs, two NAs, two H's, and two BR, so it's balanced. Okay, maybe we'll just do one more quick example. So
Oh my
we're
god, that gave me a heart attack.
I'll give you just a full blank page there.
And that would be a single replacement.
yep, so that would be a single replacement as well because we have the sodium and hydrogen switching places. What method should we use this time? Let's try potassium.
I'm ready on that one.
This one?
Stream to see.
And so I want you to write that down in a balanced chemical equation. So the reaction between potassium, metal, and hydrochloric acid. And you might hear it be called hydrochloric acid or hydrogen chloride. It's the same thing. But usually people say hydrogen chloride for the gas and hydrochloric acid for the solution, but they're the same chemical.
I left my periodic table at home.
Sure, I can do one.
Thank you.
Alright.
So you're not doing acid?
We are doing
Yeah,
it.
it's oh.
Yeah, but you gotta combine or equal it
This is
out.
practice questions.
No,
Oh, these are practice questions.
Yeah,
Because I didn't see this.
we just started.
So you're helpful. You should.
You have the document to fill in the blanks.
Yeah, we can put it up. Do you mind writing on here? Let's
Yep.
get to practice.
Is this like a stylus or you just use your finger?
Use this stylus, yeah.
Oh, okay.
Yeah, and then yeah, you can just start enter it right in here.
Oh,
Just right
neat.
on top. Yeah, and that'll be right up there.
Neat.
And then just You just gotta speak loud enough for the microphone to go.
Okay, and this is on, yeah.
Yeah, so long on usually is okay.
Hydrochloric acid, so
Yes.
that's like hydrogen chloride, right? So it's HNC.
That's right. There
You
you go.
have-
So you'll find with all the same metals, like all that first group, they're all gonna balance the same. And they're always gonna be 2 potassiums, 2 sulfates. You switch metals, and we'll get a different balance. Switch rows. But all of these, all of these are plus 1, right?
HC
Or iridium.
So for hydrochloric acid, right, it's the same as hydrogen chloride versus HCl. This is hydrogen chloride, or just
If you
HCl.
chose one of these, then it gets trickier, right? So it'll depend on what the product's gonna be. So for example, zinc would make zinc chloride. ZnCl2. That's what it's about. Yeah, so you have a new balance. From here, it's zinc is 2 plus. So it'll depend on what the ion is. So if I give you any metals, you'll have to look up what the ion is. Still have one of those notes. Exam. Oh, let's hope we get an exam.
So with these,
Hope
like,
it's
we
full.
always have a metal.
Hope that's gonna be 2 weeks and then that's it, and we get to come back, you know?
Salt and hydrogen gas.
Pretty great.
So in this example, the metal is potassium. What's the symbol for
Campus,
potassium?
Alberta just canceled school.
So
Alberta.
Actually, I was wondering that because I looked up the stats. For the 2,000 people that were tested,
Potassium is
1.5 were positive.
And then the acid is.
One in 2,000?
No, 1.5.
Okay.
Yeah, it's like that's hydrogen, that's the hydrogen.
Oh, to 2,000 people.
Yeah, out of 2,000 people in Canada that were
And then
tested,
once we have our metal with our acid.
1.5%
gas, H2.
was found that it was.
And then
1.5%.
a
Yeah.
salt,
So,
which is gonna be
out of
KCl.
2,000 people, 1.5% is,
Switch places.
30 people, right?
Yeah.
Okay.
How many people in Canada?
It's like,
How many people in Canada? Anybody know? 30 million? Let's just do 20 million to make it easy.
Yeah.
So that's 20 million.
But it's mainly hitting the elderly people and babies because, yeah, their immune systems, and plus cancer victims. Their immune systems are way down. Cancer's already taken them. So
They
this.
could live a full life with, I mean, the cancer recovery
Well, they
rates are
can,
pretty
but
high.
Their immune system is so low,
Yeah.
it's attacking that.
Well, I mean, that's 300,000 people that are at risk, right?
Yeah.
Fair number of people.
That is. fair enough.
Yeah. In the States, it's gonna be at least 500,000 people or more.
Exactly, they started to defeat it in China where it started. But all it takes is that one person may not know, but they're carrying it. Why the States or Canada is,
Yeah.
the country is infected.
Yeah, it's incredibly invasive. It's, that's the biggest problem of it. So we'll see. Hopefully these 2 weeks, this 2-3 weeks of shutdown is gonna slow that infection rate so that even if people get it, they'll at least have a hospital that won't be oversaturated. But you know, looking at Italy right now with like the amount of the oversaturation in their health department, it's like my biggest hope is that this shows like, you know, the governments that they need to put more money into public works and like supporting hospitals and
They have, yeah, they have no actual
What's
cure
the
for it.
point, what's the point that you give Messi like $50 million per year? $50 million per year,
Yeah.
and they spend they just $30 million to start search for vaccine.
Yeah.
$50 million, they need to change this.
Well, St. Barnabas goes down now.
Yeah.
I work there.
are they on shutdown now?
Well, yesterday at 6 o'clock,
they hired Impact to block off the doors.
Yeah,
They locked quite a few doors now. So they have to come in from, because the front entrance has 4 doors.
Yeah.
3 doors are blocked off, and you can only go through one, and then you gotta go through security.
and they have to wash your hands and stuff, the
Yeah,
wash hand
that's-
sessions.
And
My
then
dad
you
just
have
went
to
to
have
HSC
access.
the other day and he said that the same thing. He walked all the way around the building to try to find a door to get in.
Yeah.
For him, walking is a problem. He's in the target group that's like this at most risk, so it's a very scary time for him. It's just
This thing it just popped up at the security. They didn't even give us notice.
right.
So people are trying to get.
Things are
in the
changing every
door.
day. It's quite a stressful time.
So that 2 behind the H would actually compensate for the 2 that's ahead of the H on the other side.
Yeah, so it's
Right.
totally
This one here
balanced,
and
right?
this
Yeah.
one here. So,
Yeah.
Yeah, so with this one, the symbol for potassium is K, and the formula for hydrochloric acid is HCl. So again, we have a metal and an acid to give us our salt and hydrogen gas. So it's a single replacement reaction again because potassium started off by itself, but then it sort of stole the chlorine from hydrogen. That's pretty much the only type of reaction that we looked at so far, right? You have your metal and your acid, and we're always going to get the single replacement salt and hydrogen gas. So when we talk about properties of acids, right? We know that acids can burn us, right? So if we accidentally spill like battery acid on ourselves, or even like what other type of acids do we use at home?
Battery acid.
Or lemon. If you get lemon juice in a
Lemon
cup,
juice.
it'll hurt, right? And that's because acids are corrosive. Right? So corrosive means it can damage living tissue pretty much.
I've always had a question, okay, you have citric acid, which is in oranges or grapefruits, your stomach acid. Is your stomach acid stronger than the citric?
I think stomach acid's pH is like 1 or 2, and citric acid is a weaker acid than HCl. So yeah, I would definitely say the stomach acid's a lot stronger than the acid in fruits, for example. And you might wonder like why acids are actually corrosive and like why they can burn us. And it's actually because, and you'll learn more about this if you take chemistry in 40S, but acids produce protons, and the protons So acids produce these protons, right? And these protons actually damage the proteins that make up our body. So for example, if we're fixing a car and we get some of the battery acid on ourselves, the protons will actually start destroying the proteins in our skin. And that's why they'll start burning and being really uncomfortable. Okay, so, pardon?
Like eating away at your skin and stuff?
Yep, it will start eating away at your skin. Okay, so we know they're corrosive and they're also good conductors. So if you're a conductor, that means you can pretty much allow electricity to flow through. Okay, so does anyone have any idea why acids will allow electricity to flow?
Protons in it?
Protons, yeah, I like that answer. So, like I was saying, right, acids produce protons, which are just H plus ions. And because acids have these H plus ions, these ions are free to move, and these ions can allow electricity to flow through. So that's pretty much the reason why they allow charge to be carried. Okay, and it says that right here, so almost all acids contain hydrogen atoms. When an acid dissolves, it releases hydrogen ions into the water. So for example, we were talking about hydrochloric acid, which is HCl. Okay, we usually show the acid, so HCl in an arrow, splitting up into H plus and Cl minus. So you can sort of think of some of these acids as kind of like ionic compounds where you have the positive cation and the negative anion separating. So this is why we were saying like a bottle of HCl will carry charge because it's going to produce these ions which can flow. And we can have HBr as well, which is called hydrobromic acid. What ions do you think that one would produce when it dissolves in water?
Hydrochloric made hydrogen and chlorine, so hydrobromic makes.
So if we just look at what's on the left hand side, right? What's on the left hand side is going to determine what's going to be on the right hand side. So if we have H and Br on the left hand side, we're going to have it on the right hand side as well. So it'll just be the H plus like the previous example, and we'll have Br minus because we have bromine instead of chlorine there. And we were talking about battery acid, so it's actually has that formula. We call this sulfuric acid. Okay, and sulfuric acid, if you notice, it has two H's, right? It's a little bit different than the other acids we've been talking about so far. But it's still going to produce a proton. And then this negatively charged ion as well. So pretty much that's what makes an acid an acid. It's an acid if it produces H plus ions when it's dissolved in water. Okay, and again, HCl might be called hydrogen chloride if we're talking about the gas, and HBr might be called hydrogen bromide and hydrogen iodide and so forth. Usually when we use names like hydrogen bromide, we're talking about the gas.
Peroxide is it declared an acid,
Pardon, what was that?
peroxide?
Hydrogen peroxide, I wouldn't consider that an acid. I would consider that like an oxidizing agent, but I don't know, John, what do you think? That's a bit of a gray area.
Don't think it has. I don't think it has a pH or pKa. I think it sort of works on a different premise.
Because you got
It's real nasty. But it's
H2
different.
and O2.
Yeah. In the case of peroxide, it breaks at the oxygen instead of breaking at the hydrogen. So if you think about even water can be kind of an acid. Well, one of the hydrogens can fall off, but the peroxide it breaks in half. So you get an OH and an OH. So it's a little different. So it's not quite as clean an example.
Okay.
It's sort of it falls in a whole other subcategory of chemicals called radicals, which are really nasty. That's a real special stuff.
Yeah, because if you have
It has similar
an
effects.
injury, it still has the effect.
It uses a different mechanism, but it does have a similar effect.
Yeah.
Here we're using a proton, which is a positive thing. In peroxide, you're actually using the electron to do stuff. So that's so you're using a negative. Kind of.
Okay, just to be clear, when we're talking about protons, right, we're talking about H plus ions. They're the same sort of thing. Because an H plus ion, right, if you think of the hydrogen atom and you take the electron away, there's only a proton left. So that's why we call it proton. Okay, so acids can do environmental damage, and we also use acids a lot in industry. So again, we use acids to make batteries and stuff like that, and they're useful because they can carry charge. And it's saying here that the most important one used the most in industry is sulfuric acid. Do you remember what the formula for sulfuric acid was?
H2SO4.
Right, that's correct. H2SO4. Okay, and it's also used as a catalyst, so acids are really helpful to start reactions that are too slow to go on their own. So that's another use. And you also use sulfuric acid to make fertilizers, and interestingly to make explosives, which I've never heard about, but really interesting. So these are some common acids that we deal with in everyday life. So hydrochloric acid, a source of that's our stomachs, right? Our stomachs produce hydrochloric acid. Okay, and our stomachs produce hydrochloric acid for two reasons, right? To sort of dissolve the food that we eat, but it also kills germs. So it helps prevent food poisoning and stuff like that. And that's sort of why you could sometimes get heartburn as well. You have the acid coming up from your stomach and going into your esophagus, and that burning you sort of get in your chest is the acid burning your esophagus. Okay, and vinegar, we use that in cooking, pickling, stuff like that.
Also could be used as a cleaning.
Cleaning up.
Yeah.
And again, like if you think about like washing chicken before you cook it, for example, a lot of people use lemon juice or vinegar to kill the germs on the chicken, right? Like salmonella. Cleaning as well. And citric acid. So citric acid, like we were talking about, is in citrus fruits, right? Citrus fruits. And it's also in sour candies. So if you think about like gummy worms or Haribos or something like that, when you have all of those white crystals on the bottom, those are actually crystals of sugar and citric acid as well. That's what gives you that really sour, sharp taste. Okay, does anyone have any idea of where ascorbic acid might come from? It's actually like a really common vitamin that a lot of people should be trying to take right now.
Vitamin C.
It is vitamin C, yeah. And I think some people say that vitamin C is good for the immune system. That's definitely a benefit. You can get vitamin C also from citrus fruits and broccoli and stuff like that. Okay, any idea about lactic acid? Milk? Okay, so sometimes when milk goes sour, it has a really sort of sharp smell, right? That's lactic acid. But where else do we think lactic acid can be?
Yogurt.
Yogurt, yep.
Anything within
Dairy.
the dairy product family.
Yep, so if we're talking about lactose, right? Lactose turning into lactic acid when it goes sour. But actually, lactic acids are also in our body. So if you've ever done like a really hard workout or like walked up these stairs and you get to the top and your legs are burning, right? That's the lactic acid in your muscles burning. So our bodies pretty much produce lactic acid when the muscles aren't getting enough oxygen.
Sour muscles.
So if we're doing like really hard workout, like some sprints or the stair climb or something like that, your muscles can't get enough oxygen, so they start using a different metabolism process, and it produces lactic acid. So it produces energy, but then it also produces the lactic acid, which is why your legs get really sore. Okay, and carbonic acid is also an interesting one.
Is that what you would find in your soda drinks?
Yep, yep.
Or even the carbonated water?
Yep, so pretty much everything that's carbonated, even the carbonated water has that sort of sour taste. And it's because of the carbonic acid. Because we have carbon dioxide gas, that's what makes it bubbly, dissolving in water. Then we get our carbonic acid. And this is also what causes our oceans to become acidic as well. So when we talk about ocean acidification and corals bleaching and stuff like that, this carbonic acid here is responsible for that.
So basically, you could be putting soda cans or cloth or whatever, it's inside another acid.
Yeah, so if you think about like a bottle of Coke, for example, if you pour it into a cup and you put like a penny in it, for example, a rusty penny, all the rust will be clear. So you can actually use Coke for like cleaning like you would like an acid. So sometimes if you have like a pot that's rusty or has like a bunch of food stuck on it, some people actually use Coca-Cola to clean their pots.
Yeah.
It's just, and that's why it's sort of will cause cavities and stuff like that as well, because it's actually pretty acidic.
Yeah.
Okay, what about acetylsalicylic acid? Does that sound familiar? Okay, so I'll give you a hint. It's the scientific name for a very common painkiller. Paracetamol, not quite. It's the one that you take when you're having a heart attack.
Aspirin.
Yeah. Okay, and that's a blood thinner. So some people who have blood clotting conditions take ASA regularly because it keeps their blood from clotting as much. Okay, like we were saying, sulfuric acid again is used in batteries and fertilizers. Nitric acid. I'm not sure if I'm aware of any way that we use nitric. What do you think, John, for nitric acid?
Easy ways to think. It's also used as a strong oxidizer, so it's a little bit tricky. It's not always used as an acid. Think about that.
Maybe it's in the atmosphere, maybe, with like pollution and stuff like that.
Yeah, I think it's one of the byproducts of nitrogen pollution.
Okay, and the last one, hydrofluoric acid. I don't think we have any use for that apart from in chemistry labs because this stuff is extremely dangerous.
Nitric acid is used for making fertilizer
Oh, okay.
and TNT.
Okay, so hydrofluoric acid is actually so dangerous even at university. You're only really allowed to use it if you're like a postgraduate fellow or something like that. And it's usually under lock and key because even if you get like a drop of it on your skin, it'll burrow straight through your skin and then reach your bone, and then it'll pull the calcium out of your bones. You need calcium for all of your muscles to work right, so it can make your heart stop beating. It's like actually like super dangerous.
Just use it to clean up glass that was left over on a crucible. So you have a metal crucible with glass and you can melt the glass, dissolve glass.
Did you ever spill any?
I never really used it. There's one person in the building that was willing to use it for us most of the time. We actually had an undergraduate student, I think, who ended up using it one time. And I was like, I'm not touching that. She's like, yeah, I'll do it.
So that is far worse than a sulfuric acid.
Yeah, so I mean, like with the sulfuric acid, you can wash it off if you get to it fast enough. But the hydrofluoric acid goes through your skin, so it's much harder to wash away. I think there is an antidote. I think there's a chemical you can apply that will like extract it, but it's yeah, you have to have it on hand.
Yeah, so by that time, it's a hit or miss.
Yeah. It's nasty stuff.
Okay, so we've been talking about acid so far. So the opposite of an acid is a base. And instead of being sour like acids, bases tend to be bitter. And they're also water soluble just like acids are. And a key property of bases is that they're slippery. So if you think about anything like drain cleaner, hand soap, any sort of detergent pretty much is a base because it has that sort of slippery texture to it. And they're also good conductors of electricity because they produce ions just like acids. But instead of producing hydrogen ions when they're dissolved in water, they produce hydroxide ions.
So what acid would be in, like, say, bleach?
So in the case of bleach, we'd be talking about the opposite of an acid, which is a base. It's one of the reasons you don't want to mix your bleach with any acids, like don't mix bleach and vinegar, for example. You'd have a very aggressive reaction. Bleach and ammonia, yeah, ammonia is those are
Ammonia on its own is worse.
ammonia on its own is nasty. Yeah.
Okay, so like we were saying, bases produce hydroxide ions when they're dissolved in water. So if we think about something like sodium hydroxide, when we dissolve it in water, it's going to produce sodium ions and hydroxide ions. So we're pretty much going to have the two ions dissociating from each other. And it's all of these ions that help conduct electricity. An important thing to note with bases is just because it doesn't have an OH group doesn't mean it's not a base. And there's 2 or 3 examples that we usually think about. So that one of them is ammonia. Ammonia is a base. Okay, and ammonia is actually a base because it reacts with water to form hydroxide ions. So just because it doesn't produce hydroxide ions when it splits up, it can produce them by reacting with water. If you take 40S chemistry, you'll be doing reactions like this for months. I have a whole unit dedicated to acids and bases.
Sodium hydroxide is also known as lye. It's one of the types of lye. So if you're using lye for whatever purposes you might have, that's the one.
Get rid of it, that's good.
Okay, and just like acids are corrosive, bases are corrosive as well, so they will burn your skin just like acids. So just like protons can burn your skin by damaging proteins, so can the hydroxide ions. Yeah, so one time I was cleaning my toilet because I wanted to get it out of the way, right? So I was using one of those toilet cleaning brushes, and in the middle of it, the handle broke from the brush, and when it dropped back into the water, it threw all of the ball cleaner onto my legs and actually really burned. Like I had to immediately hop into the shower. It was shockingly painful. I didn't expect it to be that unpleasant, but it actually was pretty bad. Okay, so drain cleaners as well are extremely basic because they dissolve the hair that's plugging up the drain. Things like Drano and stuff like that. Again, it's saying here that it contains sodium hydroxide. So again, it's those hydroxide ions that are helping do all that. Because our hair is made of protein, right? And the hydroxide ions are able to break those proteins up so that the water can get through the pipe again. Okay, so just like we had a table of common acids, we have a table of common bases as well. So, calcium hydroxide, potassium hydroxide. And with calcium, for example, it was formed by calcium 2 plus and OH minus. So that's why we have the subscript of 2 here. It's because of the positive 2 charge from the calcium came down. And we use the brackets so that we know we have 2 oxygens and 2 hydrogens. And I would say the most common one that we use is sodium bicarbonate. So what do you think that is? Baking powder. Because actually a part of baking powder is baking soda. So in the UK, instead of saying baking soda, they call it bicarb. So when you go to the food store, you buy bicarb instead of baking soda. And we use that to leaven cakes and biscuits. Okay, so I think maybe for the last 2 minutes, we should just quickly review what we've done. So we pretty much talked about acids reacting with metals to give us salt and hydrogen gas. We've talked about acids and bases both being able to conduct electricity because they produce ions when they dissolve in water. And then we've gone over some of the common household acids and bases. So that's pretty much what we did today. And the only thing we skipped was the reactions with carbonates. So we'll do that next class because actually acids can react with carbonates to give us hydrogen gas and carbon dioxide gas. So we'll be looking at reactions like that in next class. And I think that's pretty much it. Any questions?
So the properties of acid will always have that single replacement with the metal?
Yeah, so whenever a acid reacts with the metal, we'll always get a salt. And whenever salts form, we have a single replacement.
I mean, if sulfuric acid, say, okay, the stuff you put in car batteries, now you're putting an acid in a plastic, why doesn't it corrode the plastic? Is it because of water inside of it?
Yeah, so they can make containers that resist damage.
Okay.
So I would imagine they use some sort of coating on the plastic to prevent the protons from damaging it.
Okay. And air conditioning fluid, is that a type of plaque or type of acid?
So I would say with coolants, it's probably like stuff like Freon and stuff.
Yeah.
I wouldn't imagine that's acidic. I could quickly Google it. It'd probably be some other sort of organic compound. It's a halocarbon, so it's just carbon atoms mixed with these elements here. So those aren't gonna be acidic.
The library, they have those on the wall. It's something like eternal, like spelled with a bunch of numbers and stuff. All right, see you tomorrow, everybody. Thanks. I'm sleepy today.
You sleeping? Oh. Good class.
Ed Meister first.